Hello people, let's take a look. So first of all, let's just read the problem and see how the illustration here would work. So let's assume the radius here is r1. Let's suppose this is the height, h1 here. This is the first circle. Well, according to the problem, it said if a right circular cylinder's radius is halved, so it means we are going to have half distance of this radius here. So what we need to do is just mark this new radius, which is half of r1, as r2. So in this situation, the height of h1 has been doubled. So we have h1 and h1 here. Now we have the new height h2. Now let us express the volume on both sides. We have the volume V1 here, which is pi r1 square h1, whereas the volume of the second cylinder is pi r2 square h2. We need to express V2 in terms of V1. And how do we do that? Knowing that R2 is obtained by halving R1, so it becomes pretty simple. So we have R2 here will be half of R1. The same goes for H2. You can guess H2 is being obtained by doubling H1, right? So H2 would be 2 times H1. Now let's replace R2 and H1 in the V2 formula. So I'm going to replace this R2. So right now what we need to do is to replace R2 by its value here and H2 by its value here. So now we'll obtain something like this. Right now what I need to do is keep the number on one side and the letters on the other side. We have V2. So as you notice it, this is the value of V1 right here. So we are going to replace V1 by its value. So this will give us half. Finally, we can now process the variation of the initial volume, delta V, which is V2 minus V1. Now, in this formula, we need to replace the value of V2 in terms of V1. We can now factorize V1 and obtain 1 over 2 minus 1, which will give us negative 1 over 2. So by multiplying 50 to both the numerator and the denominator, we get negative 50 over 100, which is negative 50%. Due to the negative that you have obtained from our calculation, we can safely assume this is a decrease.